Hello. In part one, we tore down a CoderDojo robot from my fleet. And in this part, we're going to rebuild it. There has been a release of my new Learn Robotics Programming 3rd edition book between the two, hence the delay in making this video. We're going to show how I build the robot again. We're going to show how it affects my desk space. Let's get into it. Enjoy! So the assembly of this is done in some stages. We've got a motor stage, a middle plate and a top plate. So we'll start with a motor stage. So we need that plate. We'll leave the wheels till the end. They go on right at the end. But on the motor stage, we're going to need motors. We're going to need the motor plates. And we're going to need the caster. We're also going to need 3 standoffs and 3 bolts for the standoffs. So the first thing we're going to assemble, because it kind of lines everything up, is the caster. And I just kind of finger tight push the screws through, and again, finger tight, get some nuts on, just so it's held for then tightening later. Yeah, that's nicely held. Do the same for the other side. Okay, and that's a rigid connection. You want to tighten so they're rigid. You don't want to tighten so you can't ever undo it again. So, nice balance between how far do you tighten it. I can feel it wobbling, but that's the ball inside its clips there. If you buy a new one, it may come with the ball separate, in which case you just have to push it and pop it in. Normally they don't come loose again. You probably don't want them to. There's a hole there where you could pop it back out again in the bottom of the ball caster, but I've no reason to. So the next part I'm going to do is bolt the motors onto their brackets. For this one, you want to make sure that the wires are on the inside. There's no point having the wires facing out into the world. So we'll put screws through. Plate goes on the same side the wires are, and we get a couple of nuts in here. I'm going to leave these finger tight because when we push them onto these slots, we'll want the nuts to align with the plate underneath, and then we can tighten them in against the plate. So that'll be tightening the flat of the hex nut against the plate. So we're going to leave them just a little loose now. Tight enough not to fall off, but loose enough to line up when we put it together. If you over tighten those, you'll find they don't entirely engage with the plate and go all the way down because of the corners of the hexagon poking out. We'll do the same on the other side. Screws in on this side. Plate goes on the same side as the wiring. And we can just make those, oops, so it doesn't miss thread. There we go. Perfect. Right, so those are ready. Then we need to put 3 of these standoffs in. On the lower plate, we want the rear edge to have the middle standoff, and that's so on the middle plate, the front standoff would align between the 2 ultrasound sensors, distance sensors. So we'll pop that in, put it right at the back here. And this one I tend to tighten a bit more, because if these come loose it's more problematic, because that's when the motors start to fall out. We get to use these two holes here. So if you look at the hole pattern, we have two holes all the way out there. The problem with using those holes is they put it too close to this tab on the motor, so we can't use that. So we're going to use this set of holes a little further back. And with these three, I'm going to come in and give it an extra turn with the pliers in play, just so it's, oops, there we are. Okay, so bottom layer is ready, and we'll pop those on. Now those need to be facing forward, so we need the clips to line up with these tabs. So those tabs line up with these slots. We need the tab on the motor here facing forward, so the cables are facing backwards, which means they'd align with the rear of the main board. So motors face this way, and that means they face that one middle post. Same with the other motor. Okay, so that is the first layer ready. Actually, we'll also bolt on Maker line. That's also part of the bottom layer. So for the Maker line, let's just pop these off before they fall off. So Maker line, we're going to use these two wide slots. And there's a reasonable way to align it, but it's still kind of a bit of floating thing in terms of alignment. So again, oops, again I throw the nut on the floor. So push that through. I'm going to do it in the middle here just so I have clearance to get my finger in, and then I'll slot it out to the outside, and I'll show you that in a minute, the alignment. Again, this is bolted in but quite loose at this point. And the Maker line has either these bolts or these bolts. I prefer these because I can then slide them outwards. So we align. Now, the other reason I prefer those is if you look at them, they don't really align with anything on the robot. These ones do. So because all the components are on one side, the sensors need to face, well, we'll be facing downwards. So we need to place it such that the whole of the electronics will end up facing that way, facing down. So if we're looking at the bottom of the robot, it's this way up. This one's a tricky maneuver. Well, these screws magnetized, sort of. Okay, and getting the first one in, what I've done is I've pushed the screw through. So I'm holding the screw against the Maker line gently, just so that it's held in the screwdriver. So let's get one side in loosely. Again, keeping this all loose, nothing gets tightened yet, because you have to align before you can tighten it. And the second screw, now it's kind of in, it's not going to flop around quite so much. Line that up with the standoff underneath and screw it in. Right, now we're getting closer to when we can tighten it. So what I'm going to do is, on the robot plate, these can slide around, and on the Maker line they can slide around. If I slide them all the way out on the chassis plate, then I've got one place of reference I can start to bolt down. So I'm going to grab that inside one on the all the way out slot and tighten this in on it. Okay, let's try this slightly larger spanner. Wait a minute. I think I am missing one right in between. And I suspect I know that where it's going to be is where I maintained this whole fleet before. That's frustrating. So I'm going to have to tighten that by hand and maybe later have a good look for where the other spanner is. I mean, this will tighten it most of the way. That's not going anywhere. And we'll do the same with this one. It is frustratingly close to these other brass standoffs as well, so it's quite hard to get your fingers in. And as the robot gets closer to completion, I get more desk space, but I get less working space within the robot. So, trade-offs. Okay, I'm gonna take that till it won't go any further, and that's rigid. So now we've got this part here where, although these are rigid, this is sliding around, and at this point there is no better option than to eyeball, does that line up with sensor number 3 in the middle. And once it does, make a line, sensor 3, then I can start to tighten those in. Now you'll notice as I tighten it, things want to move because you get rotation that loosens parts. That's sort of frustrating. This I want relatively tight, so once it's locked in, it doesn't change position too often. Okay, that's the Maker line attached. Not going to try and wire it just yet. We're going to wire it once we've built the second plate and put these motors in place. We'll start to wire it. We do need to wire it before we bolt plates down because it's a little easier to push cables through when it's not all bolted. That's fine. Okay, so plate 1 done, plate 2, the middle plate. So middle plate, we've got to do the opposite standoff configuration. So middle one on this front middle hole. And the 2 rear ones go in these 2 holes. Okay, and tighten those a bit. Again, I'm tightening them against my fingers because I don't want to make this. I want to make it so they don't come loose, but I also don't want to have to re-tighten them too often either. So a bit of a balance there, and that would fit like this, but there's more to do to it yet. So before we bolt it down, we're going to get the battery box in play. And the battery box needs to be at the rear, so we're using this slot here for the battery box, dropping a countersunk screw into this countersunk hole in the battery box. Now, sometimes if you buy a new one, the countersunk hole, you might need to use a countersink bit to sink it further because you really want this screw when it's dropped in. I'm going to use tweezers to drop it in. You want it to be as flush as it can get. No. You know what? I'm going to use these tweezers. You want it to be as flush as it can get to the bottom of the battery box. There we are. So that needs to feel pretty smooth. You don't want something sticking out and potentially biting the bottom of a lithium-based battery cell. So yeah, that wants to be as smooth as it can. And if it's sticking proud, take the countersunk screw out, use a countersunk bit and just push the countersunk bit a bit further in. So just ream that out gently, very gently here. Because I also, from experience, know that if you go over too heavy, you end up with screws that fall right through. So, okay, let's tighten that up. I'm tightening it with the wrong bit, and I was going, why is that going nowhere? I think that would be the right bit. I'm going to give it a little bit of clearance from those standoffs, just because that makes things a bit easier to maintain if I need to get pliers or spanners against those standoffs. There we go. Obviously this one does not need to be super accurate, it doesn't need to be super horizontally aligned, but it's just nice if it does, right? Okay, and the next part on the middle plate is we need to bolt this on. This one maybe needs a reprint, but it will hold on for now. So we'll do the reprint another time. For now, let's just put this back together. We can do a reprint without disassembling the whole robot, but there's still quite a lot of disassembly required. And we need these set of nuts. It goes into, hang on. So it goes into this set here because those bolts further back that looked perfect are where those come up. So that means it is in a floating slot, but it's mostly locked in place by that middle post. Maybe if I was to redesign, I could send them further back into these slots. That might be an idea, then it doesn't have this floating aspect to it. There we go. Always room for improvement, but to be fair, it's a fleet of, 11, and they're in use monthly. So unless that design problem becomes a major problem, I'm probably not going to change it. And with the obstacle avoiding we're doing and the precision of the RCWL sensors, the very small amount of give this has, once bolted in, won't matter. It's less than the precision of the sensors, so it's good enough. Oh, I have bottled myself in too tight and slightly snookered myself. Let's just undo that and make it loose enough to slide. So there we go, we can slide it to get both in position, because it can assume another slot like that where the other one won't line up. To line them up, you have to slide it along there. There's some trigonometry at play in that. There we are. Oops. Okay, and we'll just slide it so it's right in the middle there. Okay, again, there's a little bit of eyeballing, but okay, there we are. So that's attached nicely. Another way I might snooker myself is I might not be able to push the sensors in. Nope. Haha. Okay, we need to go back a step. Right, before we bolt that to the plate, we have to be wary that the bolt heads and the post here will stop me being able to push the sensors into their holes. And so the sensors need to slot in. Yeah, before I try to bolt this into place on the robot. And we'll align that up here. Okay, hold those two in place, start getting the nuts on them. Hold that. Spin that all the way. Do the same for the other side. I'm going to screw them in most of the way, but the final tightening will depend upon me aligning it first. Okay, now we can align that. Now that's close to quite tight. And just little nudges, there we are. Okay, right, that makes the middle layer ready, and going to leave the motors or the wheels off until we're a bit later and a bit more ready. At this point, however, we can safely place the battery in the battery box. So this was a buying mistake. There are two kinds of these 18650 cells, which are lithium ion cells. One has a flat head and one has a button head. These are the flat head kind. This battery box is really designed for the button head. It's working, it's fine, but it is a design mistake or a purchasing mistake. If I was to do a do-over, I would be more careful about selection of these just to make sure I had the stud at the end. But again, once it's in, it's fine. Now, because they're flat on both sides, you do have to pay attention to the positive sign and the negative sign. Black wire is going to be the negative wire, so needs to go, negative sign needs to go against the spring. Pop that in and clip it in place. It's safe here because it's got this nice shrouded insulated JST connector. Okay, now we can align these two. And the bit that you're going to find frustrating is you're going to have to kind of float it to go and find. Well, it might help if I put them the same way round, right? So you need to kind of float it to find the slot, line up the slots with the motor tabs. But once they're in place, they should just click over. There we go. So we can see. That's one side. There we go, and there's the other. Kind of. Wait a second, what's catching it? Probably, if I was to make a guess, one of those nuts. And that will be rigid held, and that will be rigid held. Now, holding the sandwich you've got, get the first bolts in, because if it comes loose, you are lining up those tabs again. They come loose, they come misaligned quite easily. So let's tighten one of these right up and get the other two in pretty quickly. They're slightly misaligned. There's some looseness in that. Okay. And now I've lost a bolt inside. Wonderful. So I think, because this was one of the chassis from the original set of CoderDojo robots, it's had a life of maybe getting on 6 to 8 years. So now what I've done is maybe made this too tight, and I need to loosen this off ever so slightly. There we go. So those are looser, so we can align them once it's all in, or tighten them once it's all aligned, because look, that's not quite aligned. This rear is also not quite aligned. And I guess if there was any of these bolts that were not square, you have a problem. Right, let's get my sandwich in again. See, that is not sandwiched nicely. You can see the gaps. So I've just maneuvered it till it was sandwiched a bit more nicely. There we go. Let's get the other screws in. So this is quite frustrating to do this this step anyway, because you're now fighting 5 alignment points, 2 screws, 3 screws, 2 motors, sorry. But in keeping it in front of the camera too is an extra concern. There we go, that's in, and the sandwich is still a sandwich. Oop. It's going to be easier if I put it on the end of the screwdriver and let the screwdriver align it. So what I've got is, this is a tactic I use when the screwdriver's magnetism isn't quite enough. Just keep one finger on the nut, just so it doesn't drop off the end. Especially if I'm dealing with some slightly tricky alignments. Things need to kind of use tension to line themselves back up a bit. Right, now I can tighten these right the way up again. And this is when I can come with that rigidly. So these brackets are rigidly sandwiched. Now I can tighten these motors. I don't need to hold the back because the nuts are tightening their flat edges against the two chassis that sandwich them, two chassis plates. There we go, perfect. I'm then going to take my motor wires and going to send them through the rather large servo-shaped hole. There are holes in these chassis which we haven't used but are clearly there for certain types of... Oh look, that I nearly threaded around that post. Make sure you don't do that or it'll be too short. So make sure they're clear of any posts. There we go. And now the two motor wires are up. Keep them away from the battery. Right. Just a note about these plates. So these plates are ready for further expansion. This looks like it would fit an SG09 or SC09 tiny servo motor straight up. And these look like they'd hold optical encoders if you stuck optical encoder wheels on the back of the motors. So adding optical encoders and a single servo motor for some kind of, I don't know, panning head or something. Totally, this robot is ready for it. So that is something we can expand it to. Now I'm probably going to want to make sure the number is up on the top, although this number has largely been superseded by the number on the case. So, yeah. Plus that's a terribly written 0, what can I say? Okay, it's now time for the top plate. And we've got to do a bit of preparation before we bolt it onto the middle plate. First, I'm going to swap out this sheared off standoff for a fresh one. Same M3, same length, so we can get rid of that. I can go recycling perhaps, I don't know. Check if they take nylon. So we need to identify the front and the back. On this robot, the servo hole here is always the back and the two encoder holes are the front, so that makes it relatively easy. And then we've got to put some bolts in for our shields, our panels. We're not going to put the panels on just yet because they go on after the board. So the two rear ones go into the slots. It's sort of a variable thing. We'll just make that again finger tight. It doesn't need to be terribly tight. There we are. And the front ones are similarly bolted into these slots here. That's because other holes have to be free for... Oh, I am missing one nut. It's because I need one alongside the replaced thread as well. Yes, that would lead to some confusion. Okay, the other part we're going to want are these. So with the ears poking over this, and these two holes out here are where we'll align with the posts on the middle layer, so we can't put those in that post. These could have been put in these outer ones, could be a different design, but this also aligns it better with the shield on the layer below. So the ultrasonic shield and positioner and the top shield have a nice alignment. And this is the M2.5 bolt this time, and I'm going to just loosely put this in so it's in place, but actually once the board is in position we're going to want to align these, and basically so the board will give them their alignment, and they'll get their alignment as the board actually engages. Doesn't matter that that's at an angle right now, as long as... what does matter is making sure, of course, this top part is on the same part as these posts going up. So make sure that's on the same face upwards as the posts for the shields. Covers, whatever you would like to call them. I like shields. Okay, and we'll get the other one on. Important thing is these parts are facing to the rear and inside. Okay, I might have over tightened that one a tad for this early in the build. I say it's this early, it's quite late in the build, but still this over tighten will be problematic when I fit the board. So I'm going to back that off a quarter turn or so. On the quarter turn. See, that one's perfect. This one's going between too loose and too tight. I think this bolt is actually itself a little bit stiff in its thread, which is causing some problems. So that's the top board ready for now. We're not going to put the Maker Pi in until the top board is assembled onto the middle board. Let's get some more wiring in play. So we're going to go and wire in the Maker line. That's because we're going to need to feed these DuPonts all the way through. And I've used this slot here, so it'll come out on the top somewhere. And we see, actually, have I used that slot or the opposite side? Right, here's one we made earlier. So it's this slot here. And there is wiring in the data sheet, but sometimes the best way for wiring is to have one as a reference. So we need to feed, that DuPont through the top. And remember, I'm working from the top and that's the bottom, so I need to go to the other side. We'll feed these all the way through. So I could have fed them through the slot for the encoder, but then I will narrow my options for later adding said encoder. So I'm choosing not to do that. Could they go through the wider central hole? Not at the top because where the board is. On the other layers, you know, it could do. It really could. But for consistency, I'm going to keep this the same as the rest of the fleet. There we are, that's now through. So now we are getting to, there's lots of wires everywhere. Those wires just stay at the front and it bolts in behind them. Get the ears out of the way. Right, and I now need one more M3 because one's gone astray. There were definitely enough, what was it, the 6, 12, there were definitely 12 M3 bolts on this to start with. So some have clearly gone astray over time and we're down to a smaller number. Put this on the robot side to give me space to work again. And the other problem with these, the nylon versions is of course, well actually the brass versions aren't particularly magnetic either. There we are. Okay, so now the top chassis plate is bolted onto our 3-layer sandwich. We can start figuring out wiring and tidying it up. So we're pretty close to having this together. We have all the cables coming up. We're going to need to tidy those up. We'll do that as we get the shields on. So the next major part is the board. Just pull this so in its slot. I might over tighten this one. So I want to pull it just so the ears pass here. And I have to tighten it now because I can't tighten it anymore once the board is on. So tighten it, but it's loose enough to still move, not so loose it's floppy. And with this Maker Pi, got most of the Grove connectors facing the front and the motor and power facing the back. Place that on. We need these, which are all the M2.5 screws. And I start by doing the opposite corners. Now, these brackets are 3D printed, but also I've used a tap and die set to put M2.5 taps in them. So they have been threaded properly. So they're printed a little tighter than the tap and die used to make these M2.5 threads in them. And as I tighten these, although it might slot forwards or back, it makes it a relatively good connection, and I guess it's self-aligning. I wouldn't go as far as self-stabilizing because it's not going to be perfect rigid. It can slide forward and back, but once the shields are on, you basically wouldn't notice it. Okay, so now we can start getting connected. So I'm going to flip it over. Let's make these connections. Easiest way is one we did earlier. And we have red, which goes to VCC, which is the voltage for this. We have black, which goes to GND. Ground, so the ground return path for the line detector, and yellow for the signal, which is this analog signal here. And this extra one I tend to tuck underneath, partially so no one thinks they want to reconnect that into one of these other pins. Maybe I should clip it off, but if I put it like that, well, that means sticking all the way out. I'm going to put it, let's tuck it all the way under. But yes, it does look like people do look at it and think, oh, I've got a spare connection to plug in, and they just plug it in any one of those, and no. Right. Okay. And again, with the motors, going to use an existing one. Can we see the connections? So we can just about see black, red, and black, red. So it is going black, red, black, red. Now, that keeps the code compatible, but I also say to the kids, if it goes backwards, swap pins. So easily enough done in the code. And we start off with black on that side, and also make sure they're not crossed over. So make sure they're not crossed over here, otherwise it also means you'll end up controlling the wrong motor. Again, you know, it could be that, or that's just instructions to the kids to swap the pins because maybe that's what they need. Okay, I'll tighten that in. If I recall correctly, these DC motors in the 3-layer mini round came with pin header, two-way pin header type connections, and I think we didn't crimp these on. I think we actually pried off the housing so that it could fit in this screw terminal instead, because they don't have, this doesn't have pin headers for them. It's actually relatively uncommon for pin headers to be powered motor outputs, so maybe there are a few boards where that's the case, and that's generally so they don't get confused with logic outputs, which tend to be high enough voltage to break, logic outputs tend to be low enough voltage and current that they break if you try to connect them to motor outputs or motors to them. Right, I'm going to leave that till last because there's no point powering the board yet. What we will do, we will connect the line sensor over here. Oh, that's twisted up. There we are. It goes in this Grove 6 port. And what I can do is just take up some of the slack in there. That'll probably be fine. Just tighten this one up because it's so loose it's in the way. And then we're going to connect these. Again, we make sure they end up on the same logical side. So this is for the distance sensors as the sensor. Okay, at this point, we're ready to start talking about putting the covers on. The rear cover doesn't go on until at the very end when I've connected power, but the front cover can go on a little bit earlier. Now the trick with the front cover is we're not just using it to cover it, we're also using it to manage this little nest of extra cabling for the ultrasonic sensors. Now push them aside in front of those so they're kind of behind this cover, but so they're nicely shielded, but also make sure they're not caught between any of the screws and the posts. There we are. Oh, now what happened there is these posts aren't yet aligned, so that screw slid down beside the post instead of going into it. So I'm gonna just lift that out. And these are still relatively loose, or should be. This one's actually a little tighter than it should be here. So going to loosen that one up. Because once we've got them in, we're going to need to align this top cover with the bottom cover. So we want the bolt to engage. There we are. And then just slide it to align here. Okay. Once it's aligned, we can now tighten these bolts. And it's a good idea at this point to tighten these as well. Okay, so we're on to the last few parts. Still don't put the wheels on. Wheels can go on last once everything else is on, because you lose access to a lot of these inner layer parts once the wheels are on. So again, just going to loosen these. This is where we connect the battery before this goes on. So push the battery in. And these need to slide out a bit more to accommodate it. So slightly tricky moment here. And again, what's important is both bolts engage the standoffs. And then we're going to tighten it all down. Now we can tighten these up. And this side. Okay, so those are now relatively rigid. That side here could do with a bit more. Right. Testing the rigidity as I do things. And at this point, we're ready to put the wheels on. So the wheels, we've got a slot here That slot lines up with the motor, so if you see the shape of that motor shaft as well, it's got the same kind of slot shape. Pop it on and drop a screw in. I was saying earlier that about these nylon shafts and the threads wearing, and one problem is between events sometimes hair gets wrapped up around these shafts because, well, at events I should say, because they're driven on the floor, they're driven on the various tracks and things, and people's hair sheds into it, and so I do have to take them off between events during maintenance just to remove any hair. So 0 is going to need some testing, so we'll put 0 to one side and I'll plug it in. We'll put some code on it in a bit, but let's see, because it should have, maybe it's got its test code on it. Oh, it's got someone's code on it. So it's definitely alive, it's running code. The line sensor is currently, yeah, should be the other way up, but we'll try the line sensor later. So that is one robot ready to roll, just needs some demo code on it. I hope you've enjoyed that session, tearing down and rebuilding one of my CoderDojo robots. I think after this session, 0 will ride again. I will have to put the line sensor and the distance sensor through a full test, because again, it looked like it might have suffered a bit of a shock. But it has gone together nicely, and we've replaced any of the broken bolts and got it back into service. The STLs for these are going to be made available. At the moment, they're in a Google Doc somewhere, or Google Drive, I should say, along with a bit of an assembly guide and a bill of materials. So if you'd like to try and build your own, hopefully there's enough information here to do so. As always, go make stuff and be awesome.